Hello everyone, welcome to the lecture again. In the last couple of lecture, we look at flexible cable which are hanging under its own weight or which has a uniform horizontal weight. Today, we are going to look at flexible cable which is loaded with concentrated load. So, the situation is following. Let us consider a cable that is attached to, let us say, two fixed point, let us call them A and B, and this cable supports, let us say, n vertical concentrated loads. Okay. And as we assumed previously, let us say this cable is flexible and also its weight is negligible compared to the weight of the load. So, we have, let us say, these two fixed points, let us call them A and let us say B, and this cable is hanging between A and B, and there are n number of concentrated loads. Okay. So, these are the points from where the loads are hanging. So, let us say their magnitude is P1, P2 and P3, and of course, there can be n. Now, as I said, you assume that the weight of the cable is negligible compared with the load that is supported by the cable. Okay. Now, in this kind of situation, let us assume that there are certain things we know. Okay. So, for example, let us say that the horizontal distance from, let us say, support A to each load is known. Okay. So, what do I mean by that? So, that means that from here I know at what horizontal distance P1, P2 and P3 are suspended. So, let us say this is x1. So, x1 is given to you. Similarly, this x2 is also given to you and x3 is also known. And let us also say that we also know the horizontal and vertical distance between the supports. So, what are supports here? Supports are A and B, and let us say we know where they are located. So, that means that we know the distance from here to here. This is the horizontal distance. So, let us say this is L, and let us say this L is also given in the problem statement. Similarly, its vertical distance from point A is also given. So, therefore, the knowns are L, x1, x2, x3 and D. So, in the problem statement these quantities are, let us say, given, and what you have to find is we want to determine the shape of the cable. Okay. And what is the meaning of the shape over here? That means that we want to determine the vertical distance from support A to each of the points, okay, which is let us say C1, C2, C3. So, we want to know what is their horizontal distance C1, C2 and so on, and also the tension T in each portion of the cable. Okay. So, we want to determine what is, let us say this is Y1, this is Y2 and this is Y3 and also the tension in the cable. So, this is the problem statement. So, to solve this kind of problem, first you can consider the free body diagram of the entire cable. So, this is the starting point. So, we have to first consider the free body diagram of the entire cable. How do we make the free body diagram of the entire cable? So, when we make the free body diagram, then all these internal forces we will remove, and also the supports we will remove, and we will put by a reactive force at the support. So, the situation was following: we have this point A, then we have point C1, then point C2, C3 and point B. Okay. Now, at C1 we have external loading P1, here we have external loading P2 and here I have external loading P3. Now, the tension at point C2 I am not showing here because I am plotting the free body diagram of the entire body. So, therefore, this internal tension at point C2, C1, C3 I am not showing. Okay. Now, at point B we will have the tension and it will be along the cable. So, this is the direction of the force at B. I am denoting it by force B. Now, this force, if you want, you can also resolve in Bx and By. Okay. So, if I need, I will resolve it in Bx and By. Similarly, at point A, I will have a reaction force and that will be again along the cable, let us call it A, and again I can resolve it in Ax and Ay. Okay. Now, once I draw this kind of free body diagram, then I can use the equilibrium condition. So, I can use the equilibrium condition. So, summation f x equal to 0, summation f y equal to 0 and moment about let us say point A and point B should also be 0. Okay. So, with this I can determine what are the reaction forces at A and B. So, at least one quantity I can determine using the free body diagram of the entire cable. Now, I can also consider the free body diagram of part of this cable. Okay. So, for example, because the whole cable that is in equilibrium, so therefore, its part is also in the equilibrium. So, what I can do is let us consider the free body diagram. So, as I said, we can also draw the free body diagram of the portion of the cable. Okay. So, let us say that I want to draw the free body diagram of AC1. So, I have to see what are the forces that are acting. So, let us say free body diagram of AC1. Okay. So, this is point A and this is point C1. So, at A there will be force. So, look at this, at A I have a force along the cable. So, there will be a force like this, let us call it force A, and as I said you can write it down as Ay, and Ax, and at point C1 I will have a force again along the cable. So, here, so for example, this is the direction. So, therefore, I will have a force along this line, and again I can resolve it, okay, into perpendicular forces. Okay. Also at C1 you have external force P1. Now, note that at this point I will also have a force in this direction and that direction, but since they are equal I do not need to show it over here, because we are considering the free body diagram of AC1, okay, but you can also show them and they will cancel together. Now, we can also look at the free body diagram of, let us say, AC2. So, how do I make the free body diagram of AC2? Now, I have to consider this portion of the cable. So, let us do that. So, now I have point A over here, then you have point C1, then you have point C2, and then there was point B. So, at A, as I said, there will be a force along the cable. I can divide it into AY and AX. At point C1 I have a external force P1. Now, I am not showing the forces these one, because we are looking at the free body diagram of the whole part AC2. Okay. So, at C2 you have the force P2, and then there will be another force which will act in the direction of C2 C3. Okay. So, this is the free body diagram of AC2. Now, these are the free body diagram of the portion of the cable. What we can also do is, we can also consider the free body diagram of the points from which the concentrated load are suspended. Okay. So, let us see. So, you can see here from point C1 the load is suspended, from point C2 the load is suspended. Again, since the entire cable is under equilibrium, therefore, all these points are also in equilibrium. Okay. So, let us look at the free body diagram of, let us say, point C1. Okay. So, at point C1 you have external force P1, you will have a tension along C2. So, let me call it T from C1 to C2. Similarly, you will have a force along the direction A. So, let me call it T from C1 to A. Okay. So, this is the free body diagram of this. So, you can also draw the horizontal line, and you can say, well, let us say this angle is theta 1, this angle is theta 2. So, this completes the free body diagram of point C1. Now, let us look at the free body diagram of point C2. So, let us consider point C2, and at point C2 we have an external force P2, and then there will be a tension force along, so point C2 to C3. So, it will be T from C2 to C3, and then you have a force along C1. So, this will be T C2 C1, and again we can say that, let us say this angle is theta 2 and this angle is theta 3 to find out all the forces. So, this way we can construct the free body diagram, either a portion of the cable or various points in the cable. Now, let us look at the equilibrium at point C1. So, we have to balance the forces in the x direction and the forces in the y direction. Let me balance the forces in the x direction first. Okay. So, I am doing summation Fx equal to 0 for point C1. Okay. So, I have T C1A. So, this is the tension and its component along the x axis will be cos theta 1 and this will be equal to T C1 C2 cos theta 2. Similarly, for point C2, I will have T C2 C1 cos theta 2 equal to T C2 C3 cos theta 3. Now, note that tension C1 C2 and C2 C1 they are same. So, basically you have a cable and the force is acting in that direction and the force is acting in this direction. In one case it is C1 C2 and in the other case it is C2 C1. It is the same cable, therefore, T C1 C2 and T C2 C1 it will be equal. Okay. So, this C1 C2 and C2 C1. So, as I said over here this force is equal to that force. Okay. So, either you take from C1 to C2 or C2 to C1. So, this and this are equal, therefore, this and this are equal and therefore, I can say that T C1A cos theta 1 is equal to T C1 C2 cos theta 2 equal to T C2 C3 cos theta 3 and if they are n point then it is so on. So, what are these? These are nothing but the horizontal component of the tension. So, let us denote it by T naught. What does this imply? This implies that the horizontal component of tension is same in each segment. Okay. So, with this now let us look at couple of example. So, in this question number 1, the problem statement is following. The cable AE supports 3 vertical loads from the points indicated. If point C is 1.5 meter below the left support, then in the question it is asked you to determine A, the elevation of point B and D, and B, the maximum slope and the maximum tension in the cable. So, first to solve it, let us look at the free body diagram of the entire body. Okay. So, we have point A, point B, C, D and then point E, and at point B we have external load of 30 kilonewton. At C you have 60 kilonewton, and at D we have a force of 20 kilonewton. Now, at point A the tension is, so at point A the support reaction is going to act along the cable. So, let us say this is A. Similarly, at point E it will be along the cable, let us call it E. Now, I can resolve this force A into Ay and Ax. Similarly, this force also I can resolve in Ex and Ey. Now, the dimensions of the cable is also given. So, for example, all this is given that this is 6 meter, this is 3 meter, this is 4.5 meter, and this distance is also 4.5 meter. This height is 6 meter, and this height is also given, this is 1.5 meter. Now, let us first look at the forces which are acting in the x direction. Okay. So, the forces that are acting in the x direction are Ex and Ax. So, you can clearly see that from summation Fx equal to 0, you get Ax equal to Ex. Okay. Now, to find out the other quantities, let us first take the moment about E. Okay. So, I am going to take the moment about E. Okay. So, therefore, Ex and Ey will not contribute, and I have a 20 kilonewton force. So, 20 kilonewton force into its distance from point E, the normal distance, it is 4.5 meter, plus 60 into 4.5 plus 4.5, which is 9 meter, plus 30 into 12. Now, about point E, the force Ax has a tendency to rotate like that, and Ay has a tendency to rotate like that. So, these are the clockwise direction. So, therefore, it will be negative. So, minus Ax into the perpendicular distance is 6 meter minus Ay into the perpendicular distance. So, we have to see this is 6 plus 3 plus 4.5 plus 4.5, which is 18 meter, and this is equal to 0. So, from here we get minus 6 Ax minus 18 Ay plus 990 equal to 0. Let us call it equation number 1. Okay. So, from considering the free body diagram of the entire cable, we got that Ax equal to Ex, and then we got this equation. Now, there are two variables, so we need one more equation. So, for that let us consider the free body diagram of ABC. Okay. So, let us consider the free body diagram of A, B and C. So, let us look here. So, you have point A and we have point B, then we have point C, and then there will be a force which will act along the D direction. So, at point A you have the reaction force, which I can divide into Ay and Ax. At B you have 30 kilonewton force, and at point C we have a 60 kilonewton force, and then there will be another tension T from C to D. So, this makes the free body diagram. Now, again various geometrical parameters are given. So, for example, this distance is 6 meter, this is 3 meter, and this distance is also given, it is 1.5 meter. So, let us take the moment about C. So, we have, so T CD force will go away. So, we have a 30 kilonewton force multiplied by 3. Note that 60 kilonewton force will also not contribute because it is passing through C. So, 60 kilonewton and TCD will go away. So, we have 30 kilonewton multiplied by 3 perpendicular distance minus AY into 9, because this force has a tendency to rotate like that and this has a tendency to rotate like this. So, it will be AY into 9 plus AX into 1.5 equal to 0. Let us call it equation number 2. Now, note that now we have two equations in Ax and Ay, and therefore, we can solve them. So, you can solve equation number 1 and equation number 2, and this will give you Ax equal to 90 kilonewton and Ay equal to 25 kilonewton. Okay. Now, let us find out the elevation of point B and D, which are asked in the question. So, to find the elevation of point B and D. So, let us look at the free body diagram of AB. Okay. Okay. So, here we have point A and then you have point B. At B you have external loading of 30 kilonewton. At point A the reaction force is going to act along the cable, and this is what we are keep saying. We can divide it into the vertical component AY and AX, and at B we will have a force TBC. Now, this is given, this is 6 meter, and we have to determine what is the elevation. So, let us say the elevation from point A is, let us say, YB. Okay. Now, actually we have to find out what is YB. For that, let us take the moment about B. So, if you take the moment about B, then 30 kilonewton force and TBC will not contribute. So, I will have AX into YB equal to AY into 6. And just now we have find out what is the value of AX and AY. So, AX was 90 into YB equal to AY, which was 25 into 6. This immediately gives you what is YB, and it is 1.67 meter. Okay. So, this is the elevation of point B. Now, let us find out the elevation of point D. For that, let us consider the free body diagram of A, B, C, D. So, this is point A, we have point B, point C, say point D, and then you have point E. So, at point A the force will be along the cable. So, this will be AY, this is AX, and at point B I have 30 kilonewton external load. At point C you have 60 kilonewton external load, and at point D you have external load of 20 kilonewton. Now, let us write down the other geometrical parameter. So, this is 6 meter, this one is 3 meter, and this is 4.5 meter. This was our horizontal direction, and in this direction the tension T DE will act. Now, we have to find out what is its elevation. So, therefore, from here to here let us call it YD, and we have to find out what is YD. For that, let me take the moment about D, because I do not know what is DE. Okay. So, that will go away. So, let us take the moment about point D. So, I have 60 kilonewton force multiplied by the normal distance, which is 4.5 plus 30 into 7.5 minus, because this force has a tendency to rotate like that. So, they are in the clockwise direction. So, therefore, minus Ax into Yd minus Ay into 13.5, because 6 plus 3 plus 4.5 is 13.5, and this is equal to 0. So, again we know what is the value of Ax and Ay. So, therefore, the only unknown is Yd. So, let me just write down the values of Ax. Ax was 90 into Yd minus Ay was 25 equal to 0, and this will give you Yd equal to 1.75 meter. So, we have find out what is the elevation of these points. Now, let us calculate the maximum slope. So, what is the slope? So, slope is nothing but tan theta, which is y divided by x. Now, you know what is the elevation, you know what is its horizontal position. So, therefore, you can find out the slope of all the segment, and you can see that segment DE has the maximum slope. So, let us find out that slope. So, tan theta will be 6 minus 1.75 divided by 4.5, because we are looking at the segment DE. So, let us look at this segment DE, and this distance from here to here is 4.5, and this we have just now calculated, it comes out to be 1.75. So, therefore, if you look at this triangle, then this distance will be 6 minus 1.75, and this is of course 4.5. So, therefore, tan theta will be this, and this comes out to be 4.25 divided by 4.5, and this gives you theta equal to 43.4 degree. Now, let us calculate the maximum tension. So, the maximum tension will be at the highest point, and the highest point is E. So, therefore, at point E we will have maximum tension. So, let us calculate that. T is basically E, and E is nothing but Ex plus Ey. Now, when we consider the free body diagram of the entire cable, then we saw that Ex is nothing but Ax. Okay. So, Ex is nothing but Ax, and Ax we have calculated, it is 90 kilonewton, and Ey now I can find out from the free body diagram of the entire cable, because we have to see how much force is acting downward and how much force is acting upward. So, Ay I know. So, basically Ay plus Ey should be equal to 30 plus 60 plus 20. Okay. So, Ey will be 20 plus 60 plus 30 minus Ay, and again Ay was 25. So, this will come out to be 85 kilonewton. Therefore, T or E will be square root 85 square plus 90 square equal to 123.8 kilonewton, and this is nothing but T max. Now, let us look at the second problem, and here the problem statement is following. For the cable loaded as shown, determine the angle beta 1 and beta 2, the force in each segment, and the length of the cable. Okay. So, again to solve this problem, let us first look at the free body diagram of the entire cable. So, we have point A here, point C1, C2 and point B. At point C1 you have external loading of 1600 Newton, at C2 we have 2000 Newton force. Now, at point B you will have the force along the cable. So, let us call it B, and of course, I can divide it into Bx and By. Similarly, at point A we have a force along the cable, let us call it A, and you can divide it into the horizontal and vertical component. So, this is Ay and this is Ax. Now, the geometrical parameters are given. So, this angle is beta 1, this is beta 2, this is 35 degree. So, therefore, this will also be 35 degree, and this is 6 meter, this is 11 meter, and this is 7.7 meter. Now, to find out the value of B, let us take the moment about A, so that Ax and Ay will go away. So, let us take the moment about A. So, we have 1600 force. So, about A, this will go in the clockwise direction. So, minus 1600, perpendicular distance is 6, minus 2000, perpendicular distance is 6 plus 11, which is 17, plus By, because it has a tendency to rotate in the anti-clockwise direction. So, I have taken it positive, into perpendicular distance is 6 plus 11 plus 7. So, that will be 24 plus Bx into 6, because this is 6 meter and this has to be equal to 0. But note that here this angle is known to you. So, I know what is Bx and By in terms of B. So, I can write down Bx is B cos 35 degree and By is B sin 35 degree. So, let us put it back. So, therefore, I have minus 1600 into 6 minus 2000 into 17 plus B sin 35 degree into 24 plus B cos 35 degree into 6 equal to 0, and I can find out what is the value of sin 35 and cos 35. I can put it back and find out what is B. So, this gives you B equal to 2334 Newton. Therefore, your Bx will be B cos 35, which is 2334 cos 35 degree, which is 1912 Newton. And note that from summation Fx equal to 0, this is also the value of Ax. Okay. Now, By will be equal to B sin 35 degree. So, this will come out to be 1339 Newton. Now, this we got by considering the free body diagram of the entire cable. Now, to find out what is beta 1 and beta 2, let us look at the free body diagram of let us say C2 and C1. Okay. So, first I am going to consider the free body diagram of point C2. So, the free body diagram of point C2. So, this is to find out what is beta 2. So, I have point C2. From point C2 we have a force of 2000 Newton acting downward, and then there will be tension along point B, okay. And I know the value of this tension. So, this is 2334 Newton, because just now I have find out, and I also know that it is acting at 35 degree. Now, at point C2 I will also have a tension T from C2 to C1, and it is acting at beta 2 angle. So, this completes the free body diagram of point C2. Now, let us balance the forces. So, summation Fx equal to 0, this gives you B cos 35 degree equal to T C2 C1 cos beta 2, and we have summation F y equal to 0. So, this gives you 2334 sin 35 plus T C1 C2 sin beta 2 equal to 2000. Now, since the value of B is known and cos 35 is also known, so therefore, I know what is this, and this was 1912. I can find out it is 1912 because anyway this is the force in the horizontal direction, and we know that the force component along the horizontal direction is constant throughout the cable. So, you can use this value 1912, and you can also find out from by cos 30 b cos 35, because B is known, it comes out to be 1912. So, therefore, I have the following equation T C2 C1 cos beta 2 equal to 1912, this is this equation, and I have 2334 sin 35 degree plus T C2 C1 sin beta 2 equal to 2000. Now, in this there are two variables, and you have two equation. So, from here you can find out what is beta 2, it comes out to be 19.08 degree, and T C2 C1 which is 2023 Newton. Okay. Now, to find out beta 1, let us consider the free body diagram of C1. So, let us look at the free body diagram of point C1. So, we have C1 point and the external force is 1600 Newton. Then you have the force along C2. So, T C1 C2, and I know at what direction it is acting because I find out what is beta 2. This is 19.08 degree, and then you have a force which is acting in A direction. So, it is from C1 to A, and this angle is beta 1. So, this completes the free body diagram of point C1. Now, again let us use the force balance equation. So, summation Fx equal to 0. So, I have T C1A So, I have T C1A cos beta 1 equal to T C1 C2 cos 19.08 degree, and this I already know because C1 C2 is known, and cos 19.08 you can find out. So, this comes out to be 1912. Similarly, the force balance along the y direction will give you T C1A sin beta 1 equal to 1600 plus T C1 C2 sin 19.8 degree. Now, again we have two equation and two unknown. So, we can find out what is beta 1. It comes out to be 49.78 degree, and the tension comes out to be 2961 Newton. Now, let us find out the length of the cable. So, we have to find out what is total length of the cable. So, total length is A C1 plus C1 C2 plus C2B. Okay. Now, the horizontal lengths are given, angle we have find out. So, we can find out what is AC1. So, this will be 6 over cos beta 1 plus 11 over cos beta 2 plus 7 over cos beta 3, and we can write down the values of this beta 1, beta 2, beta 3. So, this is 6 over cos 49.78 plus 11 over cos 19.08 plus 7 over cos 35, and you can find out it comes out to be 29.48 meter. So, with this let me stop here. Thank you.